Okay, so this is a ring counter. So this is an n-bit ring counter, and I'm gonna show you how a 4-bit ring counter works. So let's redraw the circuit. So we have a series of D flip-flops. So pretty much a ring counter, the output is fed back into the input. So pretty much something like this. So notice how this portion is like a ring. Okay. So after the ring counter is started, let's get the we have to like first set up initial conditions. Okay. So let's assume that the initial condition of QO was 1 and everything else is 0. So pretty much after every rising clock cycle, the ring counter is going to shift the values around. So this Q3 value is going to be shifted throughout this wire into this D, and that's what QO is going to be equal to. So let me draw it on the side. QO, Q1, Q2, Q3. At the very start, it's 1, 0, 0, 0. But when we clock it, this 0 gets transferred to this QO. So this QO becomes 0. Then the Q1 gets the value of QO. So the QO value moves to the right. The Q2 gets the value of Q1. So this 0 moves here. And then this 0, it moves to Q3. Okay? And then when we clock it again, okay, wait. Before we clock it, so this is how the new circuit looks like. Okay, so it looks something like this. We clock it again, so this moves to here. So QO is 0. This 0 moves to Q1. So Q1 is 0. This 1 moves to Q2. And then this Q2 value moves to Q3. Okay, and then the circuit looks something like this. Okay, and then we clock it again. This 0 moves to here. The QO is 0. This 0 moves to Q1. This Q1 moves to Q2. And this 1 moves to Q3. Okay, so now it looks something like this. Okay, and then when we clock it again, this 1 moves to Q0. And then all the zeros move to the right. Okay, so we're back to where we were at the start.